All right, number 1, we're finding the average rate of change from the interval from 6 to 10. So if we look at our graph, here we can see that at 6, we're here. It looks like at 9, so this is the point 6 and 9. And at 10, we can see we're here, which it looks like that's the point 10 and 15. So remember the average rate of change, we're just trying to see how the distance and time relate to each other in this part of the graph. So we're just going to find, basically we're finding the slope. So I'm going to find the difference of the y's, 15 minus 9, over the difference of the x's, 10 minus 6. Okay, so that's going to be what, 6 over 4, or 3 over 2. Okay, so that would be the average rate of change. And then what does that mean? What is the average rate of change? So I'm going to go ahead and change that to a decimal, because what that means is, in this particular case, if you look, she's throwing a ball back and forth. It's showing the distance in feet, right? So we can see here that the distance is increasing in that particular place, right? Because it is going this way. And it's over time in seconds. So the distance increases at a rate of 1.5 or 1.5 feet per second. That's what that rate of change means for that interval. Number 2 is a piecewise function. So I'm going to come down here to my graph paper to do this one. Oh, thought I had a graph paper. Let's add a page. Sorry about that. There we go. Okay, so this is number 2. So if you remember with the piecewise function, we have to go with what the constraints say. So for the first part of the function is negative x plus 3 with a constraint of x is less than or equal to 1. So I'm going to make myself a little table for this one. Now we can see that obviously negative x plus 3 is going to be linear, so I don't need a big long table. But I want to make sure and include that restraint in this table. And less than 1, that would be 0, right? So I'm going to use those 2 points. Of course, when I take and I put those back into the function, negative 1 plus 3 would be 2, and negative 0 or 0 plus 3 would be 3. So I'm going to graph. I'm going to put my graph over here. I won't need a big graph for this one. You're going to be in pretty small numbers. Okay, so for this one, 1 and 2, right? So that's where the constraint starts. I see this is less than or equal to, so I know that's an open, not open. My brain is all the way off today. That's going to be closed, right? That means that 1 is included in the answer. And of course, 0 and 3, 1, 2, 3 would be here. So if I'm graphing less than or equal to 1, I know I'm going to want this side of that function. So all of those x values are 1 or less. Now the other piece of the function, if you look at problem number 2, is 3x minus 1, but this time the restraint is we're using numbers bigger than 1. So again, if I go to make a little table, I still want to use my constraint at the beginning. I just know that this is going to be an open circle over that one, because that means that 1 is not included in my answer, but that is where it starts out. So 1 and then a number bigger than 1, so I'm going to go with 2. So 3 times 1 minus 1 is what, 2? And 3 times 2 is 6 minus 1 is 5. So I kind of hate how this happens, but it happens. So 1 and 2 is actually the same as this point, right? So I'm just going to put that there so I know that for that particular part of the function, it's not included. And then 2 and 5, 2, 1, 2, 3, 4, 5. So I can see here that that is that part of the function. Again, all of the x values that are greater than 1 would be everything to the right, so that's why I only graph the right side of the function. That's number 2. Number 3, we were talking about ceiling and floor functions. You can see here that it says ceiling. Remember, ceiling means you're going up to the next whole number. Floor means you're going down to the next whole number. So the ceiling here would be 4. Remember, this is not rounding. Think of it as a number line. If I were to graph 3.29, what's the next biggest whole number? 4. The floor would be just going in the other direction. Do be careful with your negative numbers, but that's that one. Also, remember we talked about like another way to write the ceiling of x is that symbol, and then the floor, I'll just put this here too so you can see it. We talked about how the floor symbol could look like that in case they didn't have the word ceiling or floor. Number 4, we're going to graph this one, so I'm just going to scoot back on down to my graph down here. Oops. So this is an absolute value function, which means that I know it's going to be a V shape, -2 times the absolute value of x plus 3. I'm going to, again, make myself a table. Now, one thing I did, if you were here on Friday, we talked about how, I know some basic things about this V shape before I even put it on the graph. Like, for example, I see here that there's a negative, so it's going to reflect it. I see here that I'm multiplying by 2, so it's going to get a little narrower. I see here that there's a plus 3, so the graph is going to move up 3, right? Things that we all discussed this year. So I'm just going to choose, I totally suggest using -1, 0, and 1 whenever we're doing this function because it's not moving left to right. So I know it should be centered basically at the origin. It's just going to go up 3. So that this should give me nice symmetrical numbers. Do you remember absolute values? You make things positive. So if I do -2 times the absolute value of -1, that's really -2 times 1. So -2 times 1 plus 3 would be 1. Of course, 0 is 0. So 0 plus 3. And then again, back with the 1, -2 times the absolute value of 1 is -2 times 1. Plus 3 would be 1. So those 3 should give me a pretty decent looking absolute value. If for some reason you were to put them in and you get something wonky looking, first of all, check your signs. And then make sure you're not actually moving the graph left or right. That's always important. All right, so -1 and 1 goes here, 0 and 3 is here, and 1 and 1 is here. So as we said, we knew because of the negative in front that the graph was going to be reflected, so I can see that definitely happens. It is slightly narrower than the regular absolute value graph, and the vertex of it did move up 3. So that was number 4. Number 5, we're just writing it as a rational exponent. Remember, the index here is actually the denominator, so it's going to be 4, and the exponent is going to be 7, and the actual exponent will be the numerator. So 4 to the -10/7th power is the correct way to write that as a rational exponent. Number 6, I'm leaving number 6 as multiple choice. Again, trying to be super nice on this exam. You're welcome. So one thing that I know is that I can see here that it's negative, meaning it's been reflected, right? So it's definitely not A because A has not been reflected, right? I can see there's the graph, it's going up. So it's either going to be C, B, or D. The easiest way to figure this out is just to plug a 1 in, right? Plug a 1 in. Now you can plug a 0 in, but it's going to give you -4. And if you'll notice, they all go through -4. So that's not very helpful. But if you plug a 1 in, that can give you a little bit more. So if I did -4 times 5 to the first power, right, plug a -1 in, that's going to be -20. So I need to find a graph that goes through 1 and -20. So like, for example, I can see that's definitely not C, right? 1 and -20 would be right here. So it's not C. B is kind of close, but not quite. But I can see right here definitely on D, it goes through 1 and -20. So D is the correct answer for number 6. All right, number 7. This is whenever we did growth and decay rate. So here we have a population, and obviously it is growing. So the first thing I need to do is I need to change that 3% to a decimal and add 1. So my growth rate is going to be 1.03, Again, growing goes up. If I had said decay, I would have did 1 minus 0.03. If you remember when we did these, what you're going to do is you're going to take your initial population, which is 8,600, multiply times the growth rate, and our population in our exponent is after 3 years, so to the third power. So if I were to do 8,600 times 1.03 to the third power, I get 9,397 people. That's number 7. Number 8, simplifying the sum. It's just you're just combining like terms, guys. I see here I have a 2u to the third and a 2u to the third. 4u to the third. I do not have another squared term, so that's just going to come down plus 6u squared. Please remember when you're adding and subtracting, do not change your exponents. Only your coefficients change. I only have a u term, like just one u term, so the minus 7u also just comes down. And then here I have a plus 3 and a plus 6, so plus 9. So 4u to the third plus 6u squared minus 7u plus 9. Whereas the difference is the same thing, but just be careful because it is a difference. You're going to have to subtract. So 4w squared minus 8w squared would be negative 4w squared. Negative 7 minus 2 would be negative 9w. And then negative 6 minus a negative 3 would be the same thing as negative 6 plus 3. So that would be negative 3. Combine like terms, watch your signs. Don't change your exponents when you're adding and subtracting. Whereas on number 10, we're multiplying. This is just the distributive property. Your exponents do change when you're multiplying, because if I do 3x times 2x, that's going to be 6x to the second. 3x times minus 6 would be minus 18x. Same thing with the second term. 4 times 2x is going to be plus 8x. And 4 times minus 6 would be minus 24. I can't combine those two terms in the middle. So my answer for number 10 is 6x squared minus 10x minus 24. That's number 10. Number 11, this is the difference of two squares, conjugates, however you want to think about it. The correct answer here, of course, you take the first term and square it, so that's going to be 16p squared minus the second term squared is 64. That's a really easy one. Number 12 is the greatest common factor. 5 is the greatest common factor as far as the coefficients go, and of course the variables, you're always going to want to use the smaller one of the ones they have in common, so that's going to be w to the third. So that's going to leave that as 5w to the third, right, when we take that 5 out and one of the thirds. And then that would leave 7 here and no w's left. So the greatest common factoring, that one. Number 3, this is just straight up trinomial factoring. What are the two factors of 63 that give you 16? Of course, that's going to be 7 and 9, right? So d plus 7 times d plus 9, because 7 times 9 is 63, and 7 plus 9 is 16. Number 14, we're going to do, this one's a little different. I'm going to do this one off to the side. Because we do have the leading coefficient of 5, so we do have to worry about that there. Of course, 5 is prime, so I know I'm going to have a 5x and a 1x. I just have to think about what factors of 15 can work with that 5 in order to give me a negative 22 as my answer. The correct ones you would use would be 5 and 3. 5 times 3 is 15, and that's going to work out for me because if you look, 5x times 5 is 25x, right? And then 3 times x is 3x. And I know if I subtract 25 and 3, that's going to give me 22. Now, I do need a negative 22, so that would need to be a negative 25. So I know I need a negative here, right? 5x times negative 5 is negative 25. Now I need a plus sign here, so 3 times x is positive. So the correct answer, I'm going to write it pretty right here, is 5x plus 3 times x minus 5. 15 is number 11 backwards. That's the difference of two squares. So it's just going to be 4x and 4x, right? That's the square root of 16x squared. 25 is going to be 5 and 5. And I know my signs need to be different. That's number 15. Number 16, you need the axis of symmetry. The axis of symmetry formula was negative b over 2a. And of course, as long as it's in descending order here, A, B are 2 and 24 respectively. A and B, 2 and 24, yeah. So the axis of symmetry is going to be negative 24, right, because there's a negative in the formula, over 2 times 2, which is negative 6. So again, I'm going to write it pretty over here. The axis of symmetry will be the line x equals negative 6. That means that's where the middle of our parabola is going to be. In order to find the vertex, that negative 6, as we discussed, we know that's the x value of our vertex. We just need to find the y value. So all I'm going to do is pick up my calculator, and I'm going to put a negative 6 in here. So like I would do 2 times negative 6 squared plus 24 times negative 6 minus 16. Excuse me, and you get negative 88. So that means that, ooh, what was that? There we go. That's my vertex there. Please be careful with your calculator. All right, number 17. If I divide both sides by 108. I talked about this one in class. Listen, this is one where I know everybody just hates fractions, but I promise this one's so much easier if you leave it as an improper fraction, because when you divide there, what you're going to get is 49 over 36, right? If you do that, right, you're taking the square root of both sides in order to find your solution. So it's going to be x equals, remember it is a positive and negative, and the square root of 49 is 7, and the square root of 36 is 6. Like, that's it. There's no need to have to find the decimal approximation for that one. Number 18, I just need to know the value that would complete the square. Remember, all you're going to do is take your b term and you're going to half it and square it. We discussed why in class, because we're trying to make a perfect square trinomial. So all you're doing on this one is what is half of 18 squared? So the correct answer to that, of course, is 81. 81 is the correct answer for number 18. The quadratic formula, I'm trying not to get too excited. The quadratic formula is x equals negative b plus n minus the square root of b squared minus 4ac all over 2a, right? And again, we know a, b, c is in descending order. It's equal to 0, so we're good with that one. Again, please be careful with your signs. So like on this one, since 5 is already negative, a negative negative 5 would be a positive 5 plus and minus the square root of negative 5 squared minus 4 times negative 2 times 5, and then all over 2 times negative 2. And remember how we talked about in class how we do this part in your calculator first, right? Do that first. You can't put this whole thing in your calculator. Don't try to. It's not nice. I'm going to scoot down a little bit to do this one. Let's see. You get the square root of 65. That's what you get whenever you do that part in your calculator. So I know my answers for number 19 are going to be 5 plus the square root of 65 over negative 4. And then 5 minus the square root of 65 over negative 4. And I'm going to have to do those plus the square root of 65 divided by negative 4. So this one is going to be, did I do that right? No, I put in a negative 5. That does not look right. Okay, let's try that again. 5 plus the square root of 65 divided by negative 4. There we go. That looks much better. Negative 3.2, 3.3 actually, rounded correctly. And then 5 minus the square root of 65 divided by negative 4 is going to be 0.8. Okay, so those are the answers. X equals negative 3.3 and 0.8. Those are the two x-intercepts for that function. Number 20, we're just translating it 6 left and 5 down. Please make note of that parent function, right? That's really, really important. So the function rule for the transformation, g of x equals, in parentheses, x plus 6, right? Because plus and minus are opposite, squared, right? Because it does tell me here that it's a parabola. Minus 5 for a shift down 5. 21 is the same but different, right? We're stretching this one by a factor of 7 and we're reflecting it. Do be careful. Change colors here so it doesn't get that confusing. My parent function already has a negative in a number, so I have to be careful. So g of x is going to be, of course, 6 times 7 would be 42x. And it was already a negative here, so if I reflect a negative, that's going to change it to a positive. So 42x is the correct answer to number 21. Number 22. They're asking for the conditional relative frequencies for males and females. That means these number here at the end, my totals, those are going to be my denominators on all of these. So like I know on number 22, I'm going to do 7 out of 55, right? So 7 out of, gosh darn it, 7 out of 55, I hit the wrong button on my calculator, is what, 12.7%. Right, and so that's what I'm going to do all the way down. And the next one's going to be 30 over 55, which would be 54.5%. Just finding these conditional frequencies. 17 over 55 would be 3.1%. And then, of course, 1 over 55 is going to be very small. You get 1.8%. Okay, so you're just doing those, each one over the total. Same thing for the guys, right? Except for this time, you know your denominator. Oh, by the way, that would be 100% if you did that one. Of course, it's going to be 100% on both of those because these, again, are conditional frequencies for each group. So 30 over 92 for the next one, right? So that's 32.6%. 22 over 92 would be 23.9%. 21 over 92 is going to be 22.8%. That's an 8. Sorry. And then 19 over 92. Just finding those frequencies, which is pretty easy. We think we did that quite a few times. 20.7 for the last one.